Hey, what's up guys? In this video, we're going to be diving into energy conservation, which we're going to be talking about collision. So basically, what is collision? Collision simply refers to an event where two or more bodies comes in contact and exert force on each other for a short period of time. So when you kick a ball with your foot, the impact is called collision. Because your foot is coming at a certain velocity and the ball is at a certain initial velocity, which is 0 meters per second. The impact between your foot and the ball is called a collision. So basically, what are these types of collision? In basics, we have elastic collision and an inelastic collision. But in some cases, you may include perfectly inelastic collision. So what is this elastic collision? Elastic collision is a type of collision in which both momentum and kinetic energy are conserved. An example of this collision is when two balls collide with each other. So we have a ball A and a ball B coming in contact with each other. So if they don't move with a common velocity, this is called an elastic collision. And secondly, we have an inelastic collision. What is an inelastic collision? An inelastic collision is a type of collision in which two bodies collide with each other. Let's say these are two cars colliding with each other. So in this case, momentum is conserved while kinetic energy is not conserved. It is not conserved in the sense that it is lost in form of heat or sound or even deformation. An example is two cars coming in contact with each other. So in this case, after these two cars collide with each other, they move with a common velocity either in this direction or this direction. This is called an inelastic collision. So let's basically talk about some key principles in collision. So number one, let's talk about the conservation of momentum. So basically right here, the total momentum of the system before collision is equal to the total momentum of the system after collision. So this means that the total momentum, which is the momentum of the initial, is equal to the total momentum, which is the momental final after collision, whereby the formula for momentum is equal to the product of mass and velocity. This is momentum. So in this case, the total momentum initially will now be equal to the mass multiplied by the initial velocity and is equal to the mass and the final velocity after collision. So in this case, since we are dealing with two bodies, we'll now name it mass 1, initial velocity 1 for the first mass, plus mass 2, initial velocity 2 is equal to the mass 1, final velocity 1, plus mass 2, final velocity 2. This is the conservation of momentum. So, second principle right here is kinetic energy. In elastic collision. So basically, in this case, it is similar to the conservation of momentum, which says kinetic energy initially before collision is equal to the kinetic energy after the collision, which is kinetic energy final. So in this case, the formula for kinetic energy is always given by half mass velocity squared. So in this case, we're going to be having for mass 1, initial velocity 1 squared plus half of mass 2, initial velocity 2 squared, equals to half mass 1, final velocity 1 squared plus half mass 2, final velocity 2 squared. This is the kinetic energy principle in collision. So, and the third point that we'll be making is coefficient of restitution. What is basically restitution, or the coefficient of restitution? The coefficient of restitution, which is given by E, is basically the measure of elasticity of collision, and the mathematical expression is given by the ratio of relative velocity after collision to the relative velocity before collision. And basically, for elastic collision, the coefficient of restitution is 1. And for perfectly elastic collision, the coefficient of restitution is given by 0. So, all this explanation I've been doing, what are the real-life examples of this collision? So, as I mentioned earlier, we can have collision in sports, whereby a person is kicking a ball. The foot of the person is coming at a certain speed of v, let's say 2 meters per second, and the ball is stationary with a velocity of 0 meters per second. So in this case, there will be a collision between the foot of the football player and the football. So this is an example of collision in sports. So another example is in a sudden car accident. So in this case, as I also mentioned earlier, a car moving at a certain velocity collides with another car, let's say a truck moving at a certain velocity also. Let's say this is moving at a velocity of 8 meters per second, and this car is moving at a certain speed of 3 meters per second. So the collision between the car and the truck is going to be inelastic if and only if they move with a common velocity. And if they don't move with a common velocity, the collision is going to be elastic. And this is because they move with different velocities after the collision. So basically, guys, this is the real life application of collision, and I hope you enjoyed the video. If you do so, please give me a like and don't forget to subscribe to the channel. Alright, see you guys.